Most people think they understand how big space is. They don't, not even close. And the reason they don't isn't because they lack intelligence or education. It's because the human brain was never built to process these numbers. We evolved to understand distances we could walk, territories we could hunt, spaces we could survive in. What we're about to talk about is so far outside that range that every comparison you've ever heard, every analogy, every scale model, every textbook diagram has been lying to you by omission, not exaggerating, not simplifying for convenience. Lying, because the truth is so extreme that even the most dramatic version of it doesn't fully land. Let's start close. Let's start with something that should feel manageable. The moon is 238,000 miles away. That number sounds large. It is large by any human standard. If you drove there in a car at highway speed without stopping, it would take you roughly 5.5 months. If you walked, your great-grandchildren would finish the journey. The Apollo astronauts made that trip in about 3 days. 3 days of travel to reach the closest object in space, the only other world human beings have ever physically touched. Now hold that distance in your mind. 238,000 miles. 3 days at Apollo speeds. The closest thing to us in the entire universe. The Sun is 400 times farther away. Not 400 miles farther. 400 times the entire Earth-Moon distance. The Sun sits 93 million miles from where you're standing. At the speed of the Apollo spacecraft, you would need roughly 3.5 years to reach it. Driving a car non-stop would take you about 170 years. And the Sun is our nearest star, the thing so close to us by cosmic standards that it lights our sky and warms our skin and makes life on this planet possible. Our nearest neighbor, 93 million miles away. Now we need to leave the Sun behind. Because the Sun is just the beginning of our solar system, not even close to the edge of it. The solar system does not end at Earth. It does not end at Mars. It does not even end at Jupiter or Saturn, those enormous gas giants that dwarf every terrestrial planet combined. The solar system ends, roughly, technically, where the Sun's gravitational influence finally fades, somewhere around 100,000 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, 93 million miles. Multiply that by 100,000. That is where our solar system ends. Pluto, which most people think of as the outer edge, sits at roughly 40 astronomical units from the Sun on average. Pluto is not the edge. Pluto is not even close to the edge. Pluto is less than halfway through the outer solar system by some measurements. Beyond Pluto lies the Kuiper Belt, a region of frozen objects and dwarf planets stretching out to around 50 astronomical units. Beyond that is the scattered disk, and beyond that, in the outermost reaches of the solar system, is the Oort cloud, a vast spherical shell of icy bodies so distant it takes some of them millions of years to complete a single orbit around the Sun. Millions of years, one orbit, around our own star. Voyager 1 launched in 1977. It is the fastest and farthest traveling human-made object in history. It has been flying through space for nearly 5 decades, moving at roughly 38,000 miles per hour without stopping, without slowing, propelled by a gravitational slingshot that sent it hurtling into the outer solar system with everything physics could give it. As of now, Voyager 1 is approximately 15 billion miles from the Sun. It crossed into interstellar space, beyond the boundary of the Sun's direct influence, in 2012. It is the most distant object humanity has ever sent into the universe. And at its current speed, it would take approximately 300 years to reach the inner edge of the Oort cloud. To cross the entire Oort cloud and truly exit our solar system completely would take roughly 30,000 years. 30,000 years, at 38,000 miles per hour, without stopping. Our solar system is so large that the fastest object we have ever launched, traveling for 5 decades without a single moment of deceleration, has barely left the neighborhood. Now forget the solar system, because the solar system is nothing. The nearest star to our Sun is Proxima Centauri. It sits 4.24 light-years away. A light-year is the distance light travels in a single year, about 5.88 trillion miles. Proxima Centauri is 4.24 of those, roughly 25 trillion miles from here. Voyager 1, the fastest thing we have ever built, moving at 38,000 miles per hour for 47 years, has covered about 15 billion miles. To reach Proxima Centauri at Voyager's speed would take approximately 73,000 years. 73,000 years to reach the closest possible destination outside our solar system, the nearest neighbor, the star next door. And Proxima Centauri is just one of approximately 300 billion stars in the Milky Way galaxy alone. Here is where the scale stops being a number and starts being something else entirely. If you took the entire solar system, everything from the sun to the outer edge of the Oort cloud, and shrunk it down to the size of a single grain of sand, the Milky Way galaxy at that same scale would be roughly the size of the continental United States. A grain of sand, sitting somewhere in the middle of the continental United States. That grain of sand contains the sun, 8 planets, hundreds of moons, thousands of asteroids, the entirety of known human space exploration, every place any human being or human-made object has ever been or could realistically reach in the next 1,000 years. One grain of sand in a continent. And the Milky Way is not large by galactic standards. It is a mid-sized spiral galaxy. There are galaxies in the observable universe that make the Milky Way look the way Pluto looks next to Jupiter. The observable universe contains an estimated 2 trillion galaxies. 2 trillion, each one containing hundreds of billions of stars, each star potentially surrounded by planets. The scale compounds so rapidly that the human brain genuinely cannot hold it. Not as a failure of imagination, but as a hard neurological limit. We do not have the cognitive architecture to feel numbers this large. And here is the part that should stay with you. Everything described above, every planet, every moon, every star, every galaxy, every measurement, every distance that has already shattered your sense of scale is only the observable universe. The part we can see, the part where light has had enough time since the Big Bang to reach us. Beyond that boundary, space continues. The full universe, if it has an edge at all, may be hundreds of times larger than what we can observe. Some models suggest it is infinite. Infinite space, in which our entire observable universe, 2 trillion galaxies, each with hundreds of billions of stars, is itself a small region. And inside that observable universe, in one of those 2 trillion galaxies, orbiting one of its 300 billion stars on one of 8 planets, on a thin surface layer of rock and water no deeper relative to the planet's size than the skin of an apple, is everything you have ever known, every city ever built, every war ever fought, every person ever born, every moment of human history, every sound ever heard and every word ever spoken and every dream ever had. All of it occupying a fraction of a fraction of a fraction of a fraction of what exists. The terrifying part is not the size. The terrifying part is what the size implies. If the universe is this large, and it is, the measurements are not in dispute, then our solar system is not just small. It is statistically invisible. It is less than a rounding error in any honest accounting of what exists. And yet for most of human history, we assumed we were at the center of it. We built religions around it. We went to war over it. We executed people for suggesting otherwise. The universe did not notice. It was always this size. It was always this indifferent to our position within it. The stars did not rearrange themselves when Copernicus published his model. The galaxy did not pause when we first photographed its spiral arms. Space is not impressed by us. It was here for 9 billion years before our sun ignited. It will be here for trillions of years after the last star burns out and the last atom decays, and everything we call existence fades into cold and dark and silence. We are not small in the way an ant is small compared to a human. We are small in a way that has no comparison in everyday experience. And the solar system, the vast, incomprehensible, mind-breaking solar system, is the tiniest possible proof of that.